All right, so this week, which is crazy, we're already to week 8, really chapter 7, but week 8. We're gonna discuss. Essentially, we're gonna talk about subqueries, and subqueries are just like our normal queries where we select data from somewhere with a whole select statement. The only difference is they're called subqueries because they're built into other queries. So basically, it's like a way to kind of have like a subtask within the query. So I found that the best way to kind of go through this is to actually just do the exercises, and then from there, we can just kind of talk about it as we go. So the biggest thing that you'll see kind of in this week's material reading is really there's a couple different types of subquery. There's single row, multiple row, and correlated subqueries. And I think single row subqueries is pretty simple. It just returns one row of data. The most common subquery is one that returns a single row and a single column. And those are called scalar subqueries. So you'll see some of those words. And so we'll talk a little bit about that as we go. Yeah, so let's just get started. So the biggest thing, so question number 1 says construct a query against the film table that uses a filter condition with a non-correlated subquery. So there's two different types of subquery. There's correlated and there's non-correlated. And even though it's a little backwards, I think it's a little bit easier to explain what correlated is, and then that way non-correlated is just not that. So anyways, let's say that we are going to pull a list of all the customers, select customer ID, first name and last name from customer. So if we just pull a customer first name, last name, let's say that we wanted to append a count of all of these people's sales. And I know in like a couple weeks prior, we talked about, especially in aggregation, we talked about how we could do joins. We could take customer, join it with payment, and get that with an aggregation. But there's also another way, and we'll talk about why there's two different ways here in a second. But the other way we can do it is we can write a subquery, and a subquery is simply just a like I said, it's a select statement. We just put it in parentheses inside here, and it goes. So, and typically what we do when we write a subquery is we just write the query all by itself. So in this case, we want the sum of amount from payment. And in this case, now this is where the problem is, because we want to see the total for each customer, right? So let's just use customer 1 from payment, where customer ID is equal to 1. So we can get this where the customer ID is equal to 1. The problem is when we put it in here, we want it to be pulled for every person. Because if we just put 1 here, if we just put this exactly in there, it would pull it for all of them. If we didn't have the customer ID, it's just going to get the total amount that everyone's paid. So essentially what we're going to do is we're going to take our little sample here where we pulled one example, and we're going to put it in the subquery. And I kind of like to format them like this, where they're kind of like in their own little box. And then we can say as total revenue. Now, right now, this is going to pull the same dollar amount for everybody because Mary Smith's is actually being pulled for everyone. We can see that here. So what we do is we tie this up to this. So essentially what we're going to do is I'm going to put customer C here and go C dot, and C dot, just like we would with a join. And then here I'm going to do C dot customer ID. And that's because this C dot customer ID is coming from the outside of the query. So just like functions in other programming languages, we can pass some data into here. So the subquery has access to all of the parent data, But once you're inside of this subquery, we can just select things. We can't necessarily like use stuff outside here. So we can use customer ID to put it here. And that's where the correlated comes from. So now this query is connected to the outside, right? Because we're using this from the outside inside the subquery. So that's what makes it correlated. It's tied up together. And so now if we were to run this, we'll get the revenue for each one of the customers. Does that make sense why it's correlated?
It does. I have a question though. So my
Yep.
understanding is inner query runs first, right? Subqueries run before the outside query, correct?
It depends on where it's at in the select statement.
Okay. Because my
So
confusion was, how does it know the C alias if it runs
yep.
first?
So yeah, and that's a great question. So the way this works is, if we think back to when we talk about the order operations of a select statement, essentially it's going to run the from clause first. So it's going to get all the customer information. And since we don't have anything else, then it's going to come up here to the select statement and it's going to run. So I'm glad you asked the question, because the problem is, why would we do a join when we could do this? Well, the problem is now instead of running one query, this is going to run for as many customers as we have. So this inner query, this subquery ran 600 times, which isn't very efficient, right? Because it's going to just essentially, as it selects from customer, because it's going to say, okay, I'm getting data from customer. I'm not filtering it, not doing anything else. Okay, so now I'm selecting the data. I'm printing out customer ID, first name, last name. Oh, and now there's a subquery. So I'm going to execute that. Oh, and it uses customer ID. What it returns, print, right? So it's going to do that 600 times, meaning that this subquery ran 600 times, which is not super efficient. So I'm glad you brought that up, because that's one thing I always like to stress is subqueries are, they're nice, they're shortcuts, but they always come at a cost. And the reason why they're correlated, if you ever need to check to see if is this correlated or not correlated, just take this subquery out and try to run it. If it doesn't run because it has an unknown column, then we know it's correlated, right? So in this case, this one's correlated. Anything else is non-correlated. So if we just wanted to, get something else, it would be non-correlated. But good question. And so there's a way we can kind of do this, to kind of swap this. So just like you said, the order of operations matters. And in this case, because it's in here, it's going to run after the from clause. And the from clause is always going to run first. So there's a way we can make this more efficient and I guess more join like, even with a subquery. So what I'm going to do is I'm just actually going to take this out for now. And what I'm going to do is I'm going to say left join. And this is what's really neat about SQL is we can really plug things everywhere. We can really do whatever we want. So again, I'm going to take my rule of advice, my own personal rule, and what I would recommend to everyone else is always write your subqueries externally, because that way you can see exactly what's being returned. A lot of people get weird about subqueries. They think they're hard. They're really not. You just run them by themselves. And if there is a correlated component, do what we did where we just tested it, right? Where we just put a customer ID in there. That's what test cases are all about, is just, throw in what you can test to make sure it returns what you want. So in this case, what I'm going to do is, instead of having it run 600 times for each customer ID, I'm going to actually have it create what's called a temporary table, where I'm going to pre-aggregate. So I'm going to take customer ID from payment. And since we're doing an aggregation, I'm going to call this as revenue. Since we're doing an aggregation, we need a group by. We're going to group by customer ID. And we're just going to do that. So now if I run this, we get an error, which is problem number 1. What do we get here? Oh, it's trying to run 2. So let's make sure we close that off. There we go. So now we get our customer ID with all the revenue, right? And this is the same data we were going to pull, but now we're going to leverage a join instead. And again, there's a million ways to skin the cat, because yeah, it'd be easier just to join to payment and then aggregate, but sometimes that's not the case, or we just want to work fast. So in this case, I'm just going to take this query, put it in here, take out the semicolons. Subqueries don't need semicolons. And now we got to give this temp table an alias. So I'm just going to call it CRev for customer revenue. And we need to say how we're going to join it. C.customer ID is equal to CRev.customer ID, right? Because this is what it's returning. And this is one of these multiple row subqueries that return more than one column, right? So this is returning more than one column. It's returning 2 and multiple rows, obviously, because we're getting 1 for each customer. So we're going to use this subquery to pretty much make a table that lives in memory. And then we're going to join that in memory table up to our original. And then we can just add in what we want. So in this case, CRev.revenue. And there we go. So multiple ways to skin the cat, but this one just creates an in-memory table. This is a non-correlated subquery because, again, the big test is, can we just take it out and run it? And we already know the answer to that because we tested it first. So yes, non-correlated, and it's perfect. So anyways, those are a couple quick examples, correlated versus non-correlated. And also we got into multiple tables. So yeah, appreciate that question, because yeah, it was a perfect segue. All right. Okay, so let's start on the exercises. So question number 1, it says construct a query against the film table, right? So we can kind of just go like this from film, that uses a filter condition with a non-correlated subquery against the category table to find all the action films. Category.name equals action. So ultimately, we want to find all of the action films, right? So a couple things we can do here. So if we look here at our table, inside a film, you'll notice that we actually don't have anything here, right? We don't have any category type information. If we look at our tables, you'll notice we have this film category table. So what we're going to do is we're just going to go from film F, left join, film category. We're just going to call that FC on F.film ID equals FC.film ID. Now, one kind of disclaimer I'll give right off the gate is, I wish that these examples were a little bit more like realistic, meaning like times you may want to actually use a subquery, because the real answer is we could do all this just with joins. So I always get questions, well, why don't we just do this with joins? The right answer is the honest answer is you're absolutely 100% correct. We should be using joins for this. But we're just doing this as exercises, right? So it's just practice. So yeah, I guess think of it more as a puzzle. So we're going to start off with the join here, and basically we're going to get all the categories that's in a film. Now, the interesting thing is it's possible for a film to be in more than one category. So keep that in mind. You may see one more than once right now with this join. But when we filter it down, it shouldn't be, because a film shouldn't be in action more than once. So now that we have this filtered down or joined up with the category information, now we can do our last little piece here. So it says that uses a filter condition, right? So we're going to say where fc.category ID is equal to, and now we can write, because this is non-correlated. So now we're essentially going to write our subquery. And remember, it's going to be non-correlated. So let's come down here because we can just write this one. And all we're going to do is we're going to select category ID. And just for QA purposes, I'm going to put name from category. All right, so here's all of our categories, and we want the action ones. So I'm going to say where name equals action. All right, there we go. And I'm going to take out name because we don't need that in our subquery. So there's our subquery. So I'm just going to copy this, put it over here. So again, non-correlated because we can run it all by itself. It basically returns the ID of the category whose name is equal to action. And subsequently, we'll filter the rest of our data. So now this is a list of all of our action tables or films. Does that make sense, everybody?
That one makes sense to me. The one suggestion I would have just for, I know you don't develop the curriculum, but if they would take any feedback, just on some examples, they give us what the final product looks like. And that's a lot easier to try to understand what they're doing. Because on this one here, they didn't specifically say to use the film category. And if you didn't do it, and I was trying to do it without it, because I was just trying to, they highlighted the film and they highlighted action, and I was trying to use those two tables, and you just couldn't do it. But like if they just gave the answer, sometimes I think it's a little easier, because if you don't know how to do the query, you're not gonna get the answer anyways. You know what I mean?
Yeah, for
So,
sure.
yeah.
And I guess just as a tip, I think a lot of these are straight out of the book. And I think that the answer key's in the back.
Oh,
I think. Don't quote me
I
on
know
that.
question 4 I found in the book. The rest of them I did, but yeah, question 4 was in there.
Yeah.
You know.
But yeah, no, 100% agree, and I'll take that back as feedback because yeah, I mean, unless you, yeah, because it doesn't ever mention film category, but like you said, it is needed.
And sometimes it's just hard reading the word. Like, what do you really want? If you show me what you want, it's like, okay, no, I know I'll get there. But like reading through the words and trying to decipher what is it you're looking for, and are you trying
Yep.
to trick me or not? Like.
Yep. Yeah, and
I
that's why I don't
agree.
know.
Amen.
Yep, and that's why on a lot of these I try to walk through them. And yeah. Okay, question 2. So it says rework the query from exercise 9.1 using a correlated query against the category and film category tables to achieve the same results. So essentially, this is kind of what's weird is on this one, we essentially just kind of flip this just a little bit. So this time it wants it correlated and against the category and film category tables. So essentially what we're going to do is we're going to almost use the same thing. But instead of testing against the category, we're going to just do film ID because now that's all we have to our disposal. So we're going to select the film ID from category C, left join, film category, FC on C dot category ID. It's equal to FC dot category ID, where name equals action. So we can do this. This is the non-correlated version of the same thing, right? We could get all the list of films, and I have an issue here. Subquery return. Oh yeah, it returns more in one row. So because we'd have to change this to in. Right. So as long as the film is in this one, then it would display it. So this is the non-correlated version, but obviously we want the correlated version. So basically what we do is we say, let's see, rework the.
I think you already had it. It's correlated because you have ID equals ID in your subquery.
Yeah,
Line
but
35.
this one should be able to run by itself.
Wouldn't be able to because it doesn't know the category ID equals category ID.
So it
How does
whoops, because it's because this is the FC and the C. So basically, to make this correlated, all we have to do is add f dot film ID somewhere. So where f dot film ID is in, hold on, let me think for a second. Now I got myself worked in a circle. Like I said, these are not like super practical, so you almost got to think about them. Where name is equal to action, and film. I mean, really,
Yeah, I think I did my left join, I think up above to the film category or something, and then just did film ID equals other ID, I think. I think you got more going in the middle of it than what I did.
Yeah, I think that would work. Because we need to, it needs to return. Achieve the same result. Yeah, so essentially we can just add.
You want me to look what I did and then post it?
Rework the query using a correlated subquery. Yeah. Yeah, let's see what you got. Because in the where clause, yeah, there's a couple different things we can do here. Because we could say,
yeah, like you said, there's a million different ways to solve it. That's the problem.
Yeah.
Hold on. So, Week08, right?
So let's see. Select everything from film, where the film ID. Yeah, because really we can make this just correlated by putting any one of these in here.
All right. I posted mine.
Got it. Yep.
And I did exist, what you probably wouldn't have to do.
Yeah. Basically, like the in is the same thing.
Right.
So yeah, so this is like, and that's why this example is kind of not great, because really to make it correlated, all you have to do is throw something in here, and it's really completely unnecessary, if that makes sense. Just like what you did. So you just threw fc.category ID in there. Even though, really it's it really doesn't matter too much. But yeah, essentially the same thing.
On yours, is there any reason you did left join instead of enter when it's gonna not
Yeah,
have any
and
nulls
usually
anyways?
usually just yeah, it doesn't matter here. More just habitual, really. Yeah,
Wouldn't that potentially cost more resources doing a left join than an enter join?
It may, but not enough to really like matter. Like if I was SQL tuning, it might be something that you'd come back to and fix, but but it would take a lot to get to that point, so to speak. All right, let's move on to number 3. All right, number 3. Okay, so this one's a lot more fun. This is one that I actually enjoy. So essentially what we're going to do is we're going to use a subquery to essentially, this is more like in data fabrication. So, we don't have any tables that really specify, like what we want here. So essentially what we're going to do is we're going to categorize actors based on how many movies they've been in. So obviously, if they've been in few movies, they're going to be called a newcomer. If they've been in like medium amount of movies, prolific actor. If they've been in a lot of movies, they're a Hollywood star. So we're basically categorizing them. So we can kind of take and pull this in here. So I'm just going to take this query and just kind of pull it in here. And it looks like we have an issue here somewhere. There's a typo right there. All right. So if I were to take and run this, it should just run, right? So basically we're kind of fabricating some data, right? And this is pretty normal, like for cases like where it's like, oh, I just need to really quickly, like especially in data science world, like I just want to really quickly add some like factor to this quantitative metric, just like we're doing here, the total number of movies of actors been in. Like let's say we're looking to see if there's any correlation between how much an actor gets paid and how much movies they've been in. Now, like there's a lot of different analysis we could do. We could just do it based purely on the number, but a lot of times like we need to do factor analysis. Like maybe we're doing an analysis where we want to say, oh, how, if is it more likely if someone makes more money early in their career that they become a Hollywood star? Stuff like that, which means that we need to have that outcome variable, which is more of a factor variable. So anyways, we build these factors, which are essentially categories, to lump them into. So that's our subquery. So it says join the following query to a subquery against the film actor table to show the level of each actor. Okay, so the subquery against the film actor table should count the number of rows for each actor. So let's just start off with our base kind of information. So we're going to select everything from actor, right? That's kind of our base. Woohoo, there it is. I'm just going to get their first name and last name. We're just going to get first name, last name, right? There's our base. And you'll notice that like when I build queries, I really like to layer them in components. So there's our base. Next thing I'm going to do is I'm going to build the subquery that's going to count the number of movies each one's been in. So select actor ID and then the count of film ID. And in this case, I'm a very habitual person, like to cover my bases, because I come from an industry where you hope that there's primary keys, but you don't know for sure. So I like to just always do distinct as, and let's call this let's just call this roles. How many roles have they been in films? And we're going to say from film actor. And again, we're aggregating, so we need a group by, and we're going to just group by actor ID. Right, so there's our actor IDs and how many films each one of them has been in. So there is our subquery. Now what we're going to do is we're going to take and, like I said, just layer this in. So I'm going to build my add to my base here. And I'm just going to take our little subquery and pop it in there and call that roles. And so it says, let's see, subquery against should count the number of rows for each thing. It should be compared to the min-max roles. And really it says we need to join it. So here's our subquery. We could then join it. So what I'm going to do is, let's just join it right here. Well, let's see, that'd be 2 subqueries. Sure, let's do it. We're going to build like a bunch of inception here. So we're going to join inside of here. And we're going to get our little component. Pop it in here. And we're going to call this cats for categories. And we're going to join that. So this is where our join is. So we say on, and this on is a little bit different than we ever have done, because we usually do it on keys, right? But this one's going to be a little different. So we're going to say where roles is between cats dot min roles and cats dot max roles. Right. So basically, as long as the number of roles from up here is between one of those. Now let's see if this works. First, we're not going to select anything. We're just going to see if it works. So you'll notice that it didn't work. And that's because it says roles is not supported because it's aggregated. So let's see if we can, this still shouldn't work because if we put this here, again, this all comes back to the order of operations, right? The aggregation hasn't occurred because it doesn't happen until after the from clause. So what we got to do is we got to come back to here. And essentially what we're going to have to do is we're going to have to take this subquery and join it here. And we're going to call this, let's just call it roles. And we're going to join that on, let's give this one an alias. On a.actor ID equals roles.actor ID. So now we should be able to add roles.roles. Oh, and we still have an issue here. Let's see what it is. Oh, aggregated query without a group by. So we still need to do group by actor ID. There we go. So now we have our base, which, or I guess not necessarily our base, but our next step. We have the actors and the amount of roles they've been in. So now what we need to do is we need to just join our last little bit here. Now that everything's already aggregated, now we can do our last little join against this data, just as if it were already a table. Again, we'll call this cats and we'll say on. And in this case, we're going to say roles.roles is between cats.minroles and cats.maxroles. Going to be all hungry or either wanting to go lick a rock after talking about all these minroles and maxroles. So let's go up here. And now what we're going to do is we're just going to add our level. So now we can just say cats.level and there we go. So now we can take a look and see, how many roles they've been in and the level. So in this case, Penelope Guinness has been in there 19, which is the max for this one. And so she's a newcomer. 25 for Nick Wahlberg, not to be confused with Mark Wahlberg, is a prolific actor because he's been in 25. So on and so forth. Let's take a check one Hollywood star. So 30 barely meets the cutoff for 30 is Grace Mostel. So she is a Hollywood star. All right. So that was question number 3. Let's take a look here. And so it says rewrite the following query with 2 subqueries into multi-column subquery. The subquery should use a filtered cross join between the film and actor tables. So first of all, I kind of want to just see what this does. Okay, so it gets let's see. So it gets the film, actor ID, and film ID. Okay, yeah, so this one's not bad at all. Basically, it gets any actor whose last name is Monroe and bill in a film ID. And so what I'm going to do is add in, let's just do that. So let's see if we can make this work. So we're going to basically start with the same thing here. All right, so that's where we're going to start. And now it says that it should be a multi-column, meaning it returns more than one column, and it should be a cross join. And cross joins are fun because they're easy. We can just kind of select everything. So I'm going to basically get actor ID, a.actor ID. Let's be civilized here. Actor ID and f.film ID. And we're going to select that from actor A, cross join, film F. Like I said, it's super easy. It multiplies all the possibilities, and yeah, makes it pretty easy. So then all we're gonna do from here is basically do our manual filter. We're gonna say where a dot last name is equal to Monroe. So that should whittle us down. And then if we take a look here, we can say and and f dot film or f dot rating is equal to PG. So there is our list here. So this is a cross join where we're saying that last name is equal to Monroe and the rating is equal to film. And you'll notice that we get a lot more results, and that's because we've cross joined, right? So because we've cross joined, really this is an or. It's the last name is equal to Monroe or the film is PG. So we've done a little bit of an or because we came up with every possibility. Monroe is in every PG movie and vice versa. So now what we're going to do is we are going to, so this is our subquery. So now what we're going to do is say, do we want that? Whoops. So we're going to use this fun little exists thing here. And we're still returning more. So let's take a look here. Where exists? So we're selecting the actor ID.
You want me to put in the book what they had? I literally just copy and paste the book for that.
Yeah, is this the one where it's does this use an exists? Or is it the you can just do equals here too, I think.
I just posted it in there. It was looks like a subquery, then you cross join within the subquery. I don't know. Like
Oh,
honestly,
got
I
it.
just found in the book and I was like, good enough, we're gonna learn about
Yeah,
cross
got
joins
it.
anyway. So
Yeah, so we were close. Basically, yeah, MySQL does this thing where you can explicitly specify like a kind of like two columns. So because this is returning multiple columns, we're going to check to make sure that a row matches a row. So essentially do this. So we got our subquery. And like I said, this is going to return more than what we want because we cross joined it. So we get every possibility where there's Monroe and it's rated PG. So every PG movie, every actor with Monroe. So like if we were to do this in real life with a real example, like let's use Denzel Washington, who's been in a rated PG movie. You know, it would put Denzel Washington in I don't know the rating of Harry Potter, but let's say Harry Potter, right? He wasn't actually in that movie, but because we did the cross join, we generated every possibility, right? So this is every possibility. But film actor, the film actor table up here, it only has real ones. So essentially what we're doing is a really long, inefficient way to roundabout to say that, you know, the actor is his last name is Monroe and the rating is equal to PG. Does that make sense?
Yeah, it makes sense as far as that. But yeah, like you said, it's
It,
extremely inefficient. And like why they quiz us on this makes no sense because it's almost just confusing us rather than using a real purpose for it, right?
yeah, and that's why I said it doesn't make a lot of sense, but it's more like, you know, like you said, more like the puzzle. But I agree. I don't really like it. That's why I say I really like this one because this is actually a pretty real example. The levels. But
Yeah, number 3 was cool. Yeah.
yeah, this one's weird. Okay. Rewrite the following query with 2 subqueries into 2 correlated subqueries. Okay, this is the one where you do the exists. So this is basically the same thing, but we with subqueries into 2 correlated subqueries. This one is really weird as well. So that's why we're walking through these. So question number 5. Number 5. So this one, it wants us to take essentially that same thing, but instead of turning it into one subquery, we're going to keep it 2, but we've got to make them correlated. So this one, oh, and it says as an added bit of fun, it says both subqueries should return null values. So essentially what it's saying is it should return null, which is really interesting. So yeah, this one I always like get confused because like you said, it's not practical at all. Why we would ever want a subquery to return null? It's just against everything that's been ingrained into my life. So, but we'll muddle through. So, anyways, we select the data, and in this case, we're selecting Monroe and PG, and I believe it's the same same result set as above. So essentially we want to work to the same solution, but in this case we're going to we're essentially going to kind of like do the inverse a little bit. So one way around this, I think, is we can find every, well, let's think. It needs to return null, and it needs to be correlated into 1 with 2. Rewrite the following query with subqueries into 1 with 2 correlated subqueries, and both should return null. And I know this one's in the book, but let's give it a second, see if we can come up with it for fun. I remember now. Because this one, if they're correlated, it doesn't necessarily matter what is in them, if I'm thinking correctly. It doesn't matter what they return if they're correlated, because essentially we can achieve the same result. So they return null. Select where fa.actor ID. So we're going to try this. Well, no, that wouldn't work either. This one's a really weird one. Select null. And every year I do this, and every time I see it, I'm like, oh well, naturally, it's just not natural. Okay, so let's see. So both subqueries need to return null. Both of the subqueries should return null values. Okay, well, let's just start off by making them correlated. So first we're going to get actor ID from actor. And then same thing here, film ID. I did this backwards. I mean, not that it matters, but let's do actor ID is equal to ID. And then this one in film ID is equal to ID. All right. So we run this, we should get the same results. But now we've made them correlated. So now if we were to have this return null, we would get nothing because
Didn't it return null before you put the null on there? I think the bottom two answers were null.
yeah, like it will return. Basically, the way Workbench works is that we'll add like a final row, but that's not actually part of the data. But really, these need to select null, which is the interesting thing. Where I think it's just this actually. Where exists? Let's try this. Hey, what do you know? I got it. Okay. Right. So this is the interesting one. So basically it's correlated, and the only reason this works is because of this exists. So what exists does is it doesn't necessarily look at what the subquery returns. It actually looks at the underlying data. So in this case, because we get this, because it's correlated, we just get the actor that's Monroe. And again, because this one's correlated, we just get where the where it's PG. So we ultimately end up, between two of these, every film that's Monroe and PG. And even though they return null, the underlying data has them. So as long as they exist within this query, essentially, then it passes the condition. So, in this case, hey, what's the underlying data? We don't care what it returns. What's the underlying data? Does it exist? The answer is yes. And so, bam. Anyways, this one's really weird, roundabout. My honest feedback is if this doesn't make sense to you, that's okay. You should never do anything like this, I guess, is what I'm trying to get at.
And the exist, couldn't you just put, instead of what you have, 1 equals 1, and then it's just going to return true and run anyways? Like it doesn't even matter what you put in there, right?
Yeah, really none of this matters. We do need the last name equals Monroe, because essentially we're building our filters into these two subqueries. And because both of these are correlated, essentially we're writing like two where clause, right? So we do need this little bit here from actor and from film, but because we're correlating it, they tie together. And because we have the and here, basically we get, because the film actor table is just an actor in a film. There's a lot of like setup for this, and that's why I say it's really, really specific and situational and a roundabout way of just doing something that should otherwise be very simple. So anyways, yeah, so essentially, yeah, it doesn't matter what we put here. We could say I mean, other than it says that it should return null, it really doesn't matter what we put here. It's going to return the same results because of what the underlying data is, not necessarily what it's selecting, but rather how we're filtering the underlying data in those subqueries. Because I guess the one point out of this exercise is just a good reminder that what we select doesn't matter. or what we select does matter, but that doesn't mean that what we're pulling from isn't there as well. What we select is just what we choose to display. All this underlying data exists there, if that makes sense. And that's essentially why this works, because the exists condition doesn't look for what you necessarily select. It's more of a comparison against two pieces of data. All right, so that is the exercises. And that, I think, covers pretty much all of the types of subqueries that we learn about. We did single row, we did single row containing more than one column. Well, really more than one column. Really anything returning more than one column, whether it's a single row or a multiple row, is treated as a table. The only thing that's really different is single row subqueries. And then we learned about correlated, non-correlated. So perfect. All right, does anyone have any questions? Concerns?
Hey, this is Amy. I saw that you saw my email. I'm going to do my best, and then on that URD and everything for work, and then I'll just have you look over it before I move forward, if that's okay.
Yep, absolutely.
Okay.
Yep.
Thank you.
Yeah, no problem. All right. Well, if there's nothing else, I will let you guys get back to it. And anyways, but if you have any questions, anything comes up throughout the week, let me know. But otherwise, good luck this week, and we'll talk soon.